with the Villa circle. Now in the matrix we will move on to the problem number 22. This problem says if there is a matrix, can say it now? Yes. If 2 alpha plus 1, 3 beta, 0 and beta square, minus 5 beta, this is a matrix which is equal to another matrix alpha plus 3 beta square plus 2, 0 minus 6, then find the equation whose roots are alpha and beta. So this is your task. So first your task has to be to find the value of alpha and beta, then after you can go with forming an equation of quadratic which is having two roots alpha beta. The common structure of that I will show you. First let me solve alpha beta. So from that equation, if I write it here again, this is solution I am starting. 3 beta 0 beta square 5 beta, this is given as alpha plus 3 beta square plus 2, 0 minus 6. Now as you know, when two matrices are equal, their respective elements must be equal. So from there we may find alpha beta. Here only alpha is in equation, so from there you can solve alpha, and if you see it beta, any of these two, because if you equalize this and this will be a quadratic equation, because so and you will get the same result if you go with any of the relation. You definitely get the same answer. So this is beta square minus 3 beta plus 2 is equal to 0. Now this is beta minus 2 and beta minus 1. This will be the factorization. So when one will practice factorization, so this kind of thing will come easily as I am doing. Otherwise you have to do a little bit 2 steps in between to get it this. So when you practice more, this automatically comes. So I am not going into the quadratic equation right now, how I am solving it. Just understand, you can practice at home. So beta could be 2 and 1. Now let me show you. As I said that if you do equalize this also, you will get the same answer, minus 6. So the beta square minus 5 plus 6 is equal to 0. So this could be of 2. Now you are getting a different value here. So this is equal to beta minus 3, beta minus 2 is equal to 0. So beta value here is 3 and 2. Here you are getting 2 and 1. So there should be one such value which you will get common for all this, because if you take 3 you will get different matrix. If you put 2 you will get different matrix. If you put 1 you will get different matrix. For which value of this beta both the equation will be satisfied, we have to take that value of that, because initially I have assumed that either if you equalize this or this you will get the same answer, but this time this is not happening. So what you have to choose then? You have to choose the common solution from these two. So that will satisfy both the equation, and that would be the value of beta here. So out of this 2 is common, so definitely beta value is 2, and alpha you already got is 2 and beta has to be 2. Now as I get the alpha and beta, now to form the quadratic equation, you have to go with the generalized form of quadratic equation, which is, if I say x will be the variable for that quadratic equation, so the equation can be formed as square minus alpha plus beta. Alpha and beta are the roots of that equation into x plus alpha beta. This is a generalized form of any quadratic equation where you know the roots a and alpha and beta. So respectively, if you put the value alpha is equal to beta is equal to, this will become 4x and this will become 4. So this will be the answer. Okay, so this will be the answer for this solution. Okay, so moving to next. This time it will be 23. Let me check any such variety is coming or not, because I am searching for variety, because whatever kind of thing I have shown, that I don't want to repeat it again. So I am trying for any such a variety. Okay, find the value of. Okay, let me take this. Yeah, if A is equal to, as a matrix 0 2 3 minus 4 and Ka is equal to 0 3a to be 24, then find the value of b minus a minus k. Okay, so this you have to find, where you can see a and b are some element in this matrix Ka, and k is a scalar. So as you know, a is this, so Ka definitely be how much. If I multiply k, so with this k into this matrix already given a as a, so this will turn this into 0. K will be multiplied with all the elements, 2k, 3k minus 4k. Now this is equal to this matrix, you can say this is 0, 3a, 2b and 24, isn't it? This is 24. Yes, 24. Now as these matrices are same, so 0 will be anyhow 0, 2k, if we equalize is equal to 3a. This is one equation. Second equation is 3k is equal to 2b. This is another equation. And minus 4k, this is equal to 24. This is third equation. So from third equation we can get value of k is equal to minus 6. So if we put it here, so 2b is equal to minus 6 minus 18. So your b will be minus 9. So as k, if we put minus 6, so 3a is equal to minus 12 and this will is equal to minus 4. So what are the values? The b, this you have to find. So b statewise is minus 4, minus a is k, a is minus 4. So this is minus of minus 4 and k is minus 6, minus 6 of minus of minus 6. So this is minus 9 plus 4 plus 6, that is equal to 1. So the value of this one is equal to 1. Okay. Let's move to the problem number 20. So next come here number 25. Okay. So the 25 says, yes, this is a different kind of construct a 2 cross 2 matrix where Aij, that means the element with at ith row, jth column, is defined by this expression 2i plus 3j, and this is given as a mod of this expression, means definitely the value will vary with the value of I and j. Whatever the value will come, we have to take the positive of that, means mod is representing only the numerical value without any sign significance. So even if I find minus inside, I will take plus. Plus is already a plus. So, and second thing is that as it is 2 cos 2, so I, as it is cannot be fraction, so I value will be 1 or 2, and j value also to be 1 or 2. And if I see, the matrix has to be in the form of this element A11, A12, A21 and A22. So accordingly, if we put the value of this, where II means 1 means I is equal to 1, j is equal to 1, you have to take. So if we put the value, and as you know that value will always be positive, so if I put I is equal to 1, j is equal to 1, this is equal to 3 minus 2, this is equal to 1. Now here I is equal to 1, j is equal to 2, put 1, this will be minus 2, put 2 here, 6, so this will be 4. This one 2, 1, 2 means minus 4, 1 means plus 3, minus 1 as a result, but this will be 1 as because this is a mod function. 2, 2, 4, 2, 3, 6, so this will be 6 minus 4, it will be 2. So this will be your answer for this question. Okay. Moving to next. This is a variety, may not be so tough for you, but as it is a different kind, I am showing it. Okay. So, and this is this one. Then x and y you have to find. Okay. So this case is only 26. If 4, 9, 3, 0, this is x, y square 3, 0, then what is x, y? We have to find this. Okay. So this again the similar kind. If I see it, all the as the two matrices are same, the elements must be same. So x is equal to 4 straight y, and y square is equal to 9. Now we have to find y. When we will do the square root, so this square root will give you a possibility of 2 answer, because when you do minus square, that will also be plus. When you do plus square, this is already a plus. So the value can vary. Y could be plus 3 or minus 3. You have to take both. So there are two combinations with this. So this could be this, or this could be two answer will get, and which will satisfy this relation. Okay, fine. Moving to next 27. Find the values of AB if AB is equal to, this is a similar kind, this is equal to 2A minus 3B, this also shown A plus B, sum of matrices, and this. Okay. As you know, in case of summation also, the order of the matrices must be same, otherwise you cannot do the sum. So if in case some question comes and there is a multiple choice where the order of the matrices are not same, so what would be the result of summation? So that straight away, without doing anything, you can say there is not possible. So this kind of problem is given, but I am not showing it as because it is very simple. Unnecessary time will be killed. The inverse. If you have remember what is additive inverse of a matrix, I am not showing it. I just took additive inverse of a matrix. Any matrix is that which, when added to it, will give you a null matrix. Means answer is 0. So additive matrix, additive inverse matrix. The term is additive inverse, that I shown you in theory. Inverse matrix of a matrix is that when we multiply the matrix with -1 scalar. So this is my direct answer to this kind of thing. Okay, so if you have to find any additive inverse matrix of a matrix, then only thing is that you multiply the matrix with -1, you will get the answer. Let me show you some example that is given here. This is very simple problem. Even still even I am showing you. A is given as 1, 4, 7, -7. This is -3, 2, 5, 2, 3, -1. So we have to find the additive inverse matrix. Let it be -1 will be additive into a matrix. So we have to multiply with -1 to this matrix. 2, 5, 2, 3, -1. So what we have to do, we have to multiply -1 with all. Ultimately this is -1, nothing will change in the numerical value, only minus will be adjusted inside, and accordingly the signage will change. That is the only thing which will happen to the matrix. Okay, -2, -3 and +1. So that is only 1. So this will be your additive inverse matrix. Okay, to the matrix A. Okay, this will be your answer. So this is one kind, but I need to be so. Okay, let's move to other variety. 28. It is there. Let me see. Okay, let me take this. If A is A, B, B, A is the matrix, and A square is alpha, beta, beta, alpha, then find alpha and beta in terms of A and B, that you have to find. Okay, so the solution would be, now this is A square, so anyhow you have to find A square. So A square means A into A, so that means when you will multiply AB BA with itself, so you will get the answer. So this is how much? A into A square, B into B square. Okay. So this is B square. Now again A into B into A 2AB. This one AB, that means 2AB, and this is B square plus A square. Okay. So this is equal to alpha and beta, alpha, beta, beta, alpha. So if we equalize the same, so alpha is equal to A square plus B square, and beta is equal to AB. So anything you equalize, here also if you equalize, this will give you the same. So this is alpha and beta in terms AB you can find. Okay. So here I will end this session. In the next session I will move from problem number 29. Thank you for now.